Today we are working on section 6.6, which is to solve absolute value inequalities. The other day when we were together, we were working on equations, and today we're doing inequalities. Now, I'm going to give you a moment to jot down what's up here, and then I'll explain it. Just like we had absolute value equations where we set what was inside here equal to a positive and a negative number, we're going to work that same idea where it's like, okay, what's inside here? Could be positive or could be negative, whatever number's on the other side. The deal is, now with inequalities, that gets us into and or statements. Okay, so we're going to take what we learned in 6.4 about ands and ors and what we learned in 6.5 with absolute values and put them together in 6.6. This is a greater than or equal to statement, greater. Thus, this is going to be an or statement because the symbol up there is a greater symbol. And so when I work down here, notice I have the word or written in between. And I have written the x is greater than or equal to 6, just like it is up above. Absolutely the same. But notice what happens when I make this a negative 6 over here. Do you notice what happens to that inequality symbol? I flipped around, exactly. And that's what's going to happen every time you write the negative inequality. You are going to flip that inequality symbol. Please jot yourself a note about that. Every time you set up your two inequalities and you write the negative one, you are going to flip that inequality symbol. Now, you guys know from section 6.4 that or statements stay as two separate statements with the word or in between. And you also know that when you're graphing them, that the arrows should be going in opposite directions. Rebecca.
After, what did you say, every time you set the two inequalities and the...
Every time you set up the two inequalities from your absolute value, when you write the negative inequality, you have to flip your inequality symbol. Does that make sense? Mm-hmm. Okay. Every time, even when we work with the and statement in just a little bit, we'll do that same idea. We'll go a little different direction after that, but we'll go with that same idea. Any questions there? This is the most easy form of inequality statement because there's only an x inside the absolute value bars. Okay. Later, as we start working with like x minus 3 and 2x plus 5 inside there, we'll actually have to do some solving in order to get down to the last two inequalities. But here, we didn't have to solve it all. We just set them up. So is there any trouble just in setting things up? Let's go on. Okay, set up, Colin. Thank you. I'm going to pause on this one also and let you jot down for a less than. When you have the less than or equal to symbol, you will always have an and statement when you get done. When I started working this out, I have my x and my less than or equal to and my 0.5, just exactly like the problem began. Exactly. Then I have my word and. Okay, I'm starting this out where I'm writing two inequalities. We'll put them together in just a moment. And notice then, on the other section here, when I have that negative 0.5, what happened to my symbol? It got flipped around. That's right. I have a greater than or equal to rather than the less than or equal to. Now, because it's an and statement, I have to put the two together as a compound and statement. They have in common, they have this x in common, so that's what gets put in the middle. Then I look at that and I go, okay, x is less than or equal to 0.5. Well, I had my 0.5 here, so that's where my less than or equal to goes. How about this part over here? Compare it to this and tell me how they're different. Tell me how they're different. Kayla?
We flip the 5 and 6 around, and then you flip the sign.
Exactly. Remember when we were talking just a little bit ago when we were going over problems, we said if you flip your sides of your inequality around, you have to flip the inequality symbol also. And so now this looks like negative 0.5 less than or equal to x less than or equal to 0.5. And when we graph it, we've got negative 0.5 and positive 0.5. We're going to put a closed circle on each of them. All x's less than or equal to 0.5. Arrow goes left for less. Okay? All x's, now I'm going to read this backwards. All x is greater than or equal to that negative 0.5. Which way is the arrow going to go? To the right. So I actually have that box over top, just like we had in section 6.4 for the and statements. That's how it should end up. Because we can pick any number between negative 0.5 and 0.5, and it will make this a true statement. Give me a number that's between these two. Volunteer with a number that is between these two on the number line. Jake? 0.1. Absolute value of 0.1, Jake? Is that less than or equal to 0.5? Yeah. Cool. Let's take a number that's outside that area. Give me a number bigger than 0.5. Nick?
1.
1. Absolute value of 1, Nick?
1.
Is 1 less than or equal to 0.5?
3.
Is it less? True or false?
False.
False, thank you. And it should be false because we don't want anything out here to be working, okay? Only the numbers that are inside here are what we want to work. I could put 0 in. The absolute value of 0 is? Is 0 less than or equal to 0.5? Yeah. Angela?
Why couldn't the last equation not be an and statement?
Let me go back to this one and let's test what we had for answers, okay? I want any numbers that are greater than or equal to 6 or are less than or equal to negative 6. So give me a number, Angela, that's less than or equal to negative 6, please.
Negative 7.
Negative 7. Absolute value of negative 7? Is 7 greater than or equal to 6? Is that a true statement? Okay. Give me a number that's bigger than 6. Okay. Absolute value of positive 7? It's greater than or equal to 6. Makes it a true statement out here. Now give me something that's between 6 and negative 6. Okay. Absolute value of 3? Is that greater than or equal to 6? So something in between the two is not going to work.
So would every greater than or equal to problem, would that always be an or?
Yes.
Always?
Always. Once you get your absolute value bars all by themselves, then you get to decide if it's an and or an or. Don't make that decision prior to that when you've got addition on the outside and division and all multiplication. Because sometimes when we divide or multiply by a negative, remember it flips that symbol on us. That will cause that and or to change then. So decide whether it's an and or an or with your absolute value bars being all by themselves and the other stuff on the other side.
How do we decide when they're all by themselves?
If it's a greater, it's an or.
Okay.
If it's a less than, it's an and. All right? Hear that mnemonics? All right. So here we had our less than. It's an and statement. So let me jump to here for just a second. If you don't have this down in your notes, please put this in your notes. Greater is an or. And I don't care if it's a greater or a greater than or equal to. It's the same thing. Okay? As long as it's a greater. Less than is an and. And I know I took a little liberty with spelling on the word greater. It's actually ER, isn't it? It's not that Mrs. Deegan doesn't know how to spell. I was trying to make you remember. All right? Greater. So you got that in your notes so that once you have the absolute value bars all by themselves, greater than a number, or the absolute value less than a number, then you get to decide and or. This one is an or. This one is an and. Can't have anything added, anything multiplied, anything subtracted, nothing else on the outside of the absolute value bars. Let's go back to this one. Well, all we're going to do is set this up. I did the absolute value bars all by themselves, less than or equal to 8. Is it an and or an or statement, first of all? And statement. Okay, once you jot down what you think are the two inequalities that you're going to have with the word and in between, and then I'll help teach you how to put them together. Let's jot down the two inequalities that we have here. Do I volunteer for the first inequality of what's written down? Cecilia.
X is less than or equal to 8.
Exactly. X is less than or equal to 8. So where we began. Then we're going to put down the word and, because you guys told me it was an and statement. And what's the other inequality that we're going to have written? Jack? Yeah, you were raising your hand, Jack. Perhaps you were stretching, but it looked like you were raising your hand.
X is greater than or equal to
Thank you. X is greater than or equal to negative 8. Now, when I set up and statements, the easiest way that I know to set them up is to put the smallest number on this side and the largest number on this side with the X in between, because that's what's in common. So I'm going to put the largest number here and the smallest number on this side. Isn't that how our number line goes, from small on the left to large on the right? Then I look and I go, well, this would be the same way this is. So what symbol do I get to put in there? These are written exactly the same. What symbol do I get to put in? Less than or equal to. This one is written how? Would we say backwards? Yeah, the sides are flipped around, aren't they? So what do we have to do to our symbol? Ladies, gentlemen, I want to hear you. What do we have to do to our symbol? Flip it around. So here it's a greater than or equal to. It's not that I'm changing what the symbol is. I have to flip it around in order to make this inequality still a true statement. Okay? Kayla.
Why isn't it less than or equal to at first, like the X is greater than or equal to negative 8?
When I write them down, I write down this exactly as it is from the problem. Your positive number is exactly as it is from the problem, always. Your negative number has to have your symbol flipped. I think what you're asking me, Kayla, is could I write down X is greater than or equal to negative 8 and X is less than or equal to 8 like this? Sure. But notice I flipped the symbol because of that negative 8. Notice that my other one is exactly as the problem was. That's what I'm trying to get across to you, is that the positive one doesn't change at all. But the negative one, yes, you have to flip the symbol around. Okay? In the end, Kayla, we're still going to end up with this as our compound inequality. You with me there? Okay. Anybody else? Rebecca.
How would you graph that?
I'm going to put negative 8 and positive 8 on it. Will these be open or closed circles, Rebecca?
Close.
Now, I need all x's that are less than or equal to 8. Which way is that going to go? Less than or equal to 8.
Yeah.
Less than is going this way. Now, I'm going to read this one backwards, Rebecca. X's that are greater than or equal to negative 8. Notice how I'm going that direction. I'm reading it backwards. X is greater than or equal to negative 8. Which way is that arrow going to go? That's correct. We're going to go like this. Can you see how reading that backwards might help you in that and statement? Okay. Now, for those of you who are astute enough to be able to go from here to here without needing this, if you can do that, awesome. If you can't, please take the intermediary step there of writing the two statements with and then combining them. But if you can go straight down here and you write it correctly that way, Awesome. What do you notice about and statements and these two symbols here? They're going the same direction. They're both less than or equal to when we look at them in an and statement. Okay, that's what they look like. So just be aware of that. Let's jump to this one, please. Absolute value of V is greater than 2/3. Okay, absolute value bars are all by themselves, and it's greater than 2/3. And or an or, ladies and gentlemen. Or, write down what you think are the inequalities for this, please. All right, Ellie has up here V is greater than 2/3, or V is less than negative 2/3. Absolutely what we should have. If your notes don't say that, make sure that they do. She took what was inside absolute value bars. That's exactly the same thing. But notice here this got flipped because of the negative that we put in there. Or statements are left as two inequalities. How would this look graphed? Well, let's put it on. We've got 0 and 1 and negative 1. Where is 2/3 compared to 1? Angela?
It's almost.
It's almost to 1. Okay, so it's a little more than half, right? So we're going to call this 2/3 over here. 2/3. V is greater than 2/3. Which way does the arrow go, ladies and gentlemen? Greater. Which way? To the right. We got an arrow going this way. V is less than negative 2/3. That's going to be over here. I got negative 2/3. Which way is the arrow going to be? To the left. That's right. These two answers are going in opposite directions, and that's the way an or is supposed to look. Remember we talked about in the compound statement 6.4, if you got the Egyptian thing going on, you did something wrong. Ands go towards each other, ors go away from each other. If you got this other thing going on, too bad that it's not a real video, right? They can see me doing this. Okay. Any questions there? All right, I told these girls over here we got to up what we're doing, up the difficulty level a little bit. Wait, what?
Why do we have to have it in between the numbers for the 4 and the like we could just write negative 8 and then we don't have to have a number to use that. Yeah, we just put 2 numbers, negative 2/3 and then over here is 2/3.
On the and statements?
Yeah.
Just those 2 numbers are fine with me on the number logic compound. I had told you that 6.4. So,
but can we not do it with the
or? With this particular or one, there were fractions. Show me where those are in reference to the integers on the number line.
Okay.
Does that make sense?
Yeah, so if it was full numbers, then you could just write.
Just the integers, you could just put those 2 numbers down.
Okay.
Okay. Now I understand your question. Okay, we've already talked about this, the greater and the less than. So now we need to go to make it a little bit harder. We've got an expression inside the absolute value bars. This doesn't change much. I've got absolute value bars greater than or equal to 7. Is it an and or an or? Or, very good. Absolute value bars all by themselves. So set up your 2 inequalities, will you please? Show your neighbor. So Rebecca gave us x minus 5 is greater than or equal to 7, or x minus 5 is less than or equal to negative 7. If you don't have your notes that way, please jot them down. I had Rebecca write them one on one side and one on the other because we have to solve each of the inequalities rather than writing them one on top of another. X minus 5 greater than or equal to 7. What's the solution to this inequality, please? The solution to this inequality. Cecilia?
X is greater than or equal to 12.
Exactly. X is greater than or equal to 12. Could I have the solution to the other inequality, please? X minus 5 is less than or equal to negative 7. Ben?
X is less than or equal to negative 2.
All right. We're going to carry that word or down with us into our answer. And once you have just X in each of them, that is your solution. And we can graph that. We'll show how we're graphing that with the negative 2 here and the 12. X greater than or equal to 12. Open or closed? Closed. Arrow to the, okay. X less than or equal to negative 2. Open or closed? Closed. Arrow to the left. So, Cecilia, just the two numbers there would be appropriate. Okay. Now, let's check to see if one of those numbers actually works. Give me a number that's less than negative 2. I want some number less than negative 2. Kyle?
Negative 5.
Negative 5. Negative 5 minus 5, Kyle. Absolute value of negative 10. 10 is greater than or equal to 7. True or false? All right. I want a number bigger than 12, please. Bigger than 12. Jordan. 15. 15 minus 5, Jordan. Absolute value of 10. 10 greater than or equal to 7. True. Any number from the left, any number from the right will work. Let's prove that one of the numbers in between does not. Give me some number in between here. Ellie?
7.
7. 7 minus 5, Ellie.
2.
Absolute value of 2 is 2 greater than or equal to 7. Okay, false statement. Okay, Jake, question?
Wouldn't 0 minus 5 be greater than, wait, no? Oh, never mind.
All right.
I said really stupid.
All right. Think about before you ask. That's true. All right. Anybody else? Let's go on here then. Ooh, I just made it a little tougher, didn't I? Absolute value of 4x minus 5 plus 3 on the outside is less than 9. I'll pause it. All right, you got that written down? Because what's the first thing you have to do? First thing, Lucy?
Subtract the 3.
Thank you. Subtract the 3. That's the first thing you have to do. Lucy, what will that give you on the right-hand side?
6.
6. Then I've got this negative 4x minus 5 in absolute value bars and the less than sign. Now you get to decide if it's an and or an or. Which one is it, ladies and gentlemen? And. Very good. Set up your and statement for me, please. If you look up at what Angela has written on the board, negative 4x minus 5 is less than 6, and negative 4x minus 5 is greater than negative 6. We can put these together. We can do that. Because this 4x, negative 4x minus 5, and this negative 4x minus 5, aren't they the same thing? Yes, no? Yes? Put it in the middle then. Negative 4x minus 5, I'm putting that in the middle. Where do I put the small number? On the left. So I'm going to put the negative 6 over here. And where do I put the large number? On the right. Okay, now, I have negative 6 is what then, that negative 4x minus 5? What symbol should I put in there? Any thoughts? Jordan? It should be a less than, because when we look at this, whoops, daisy, this has to be the that idea. It has to be this idea because we had these two flipped around, so we need that less than symbol. How about the negative 4x minus 5 compared to 6? What are we going to put in there? What are we going to put in there? I don't want greater than. That's not a greater than symbol. That's a less than symbol. This one comes straight in there. They're both the same direction, right? Now you can solve it as an and statement. What are you going to do first to solve it as an and statement? You're going to add 5 to everything. So add 5, add 5, add 5. What will happen on the left-hand side when you add 5 there? Colin, what do you get on the left hand? A negative 1. And then what do you get in the middle?
Negative 4x.
Negative 4x. And what do you get on the right? 11. Okay. Now what do we do? Quitting is not an option. What do we do next? Cecilia. Divide everything by a negative 4. Okay. What happens when we divide by a negative, ladies and gentlemen? The sides flip, that's right. So a negative divided by a negative is a positive. So I have positive 1/4 greater than x greater than, what's the other number? Can I have an improper fraction? You bet, negative 11/4. Okay, now, when you look at that, are you guys used to having the positive number on the left and the negative number on the right? Is that how your brain works? Do you like it? You don't like it. Angela's going, I don't like it. Jake?
I just think the two inequalities, I just like simplified them and then I put them together.
You can do that too. You can do that too, that's fine. If you flip these around, notice that now you have those two less thans there because the smaller number's on the left, the larger number's on the right. And we could graph this. We could graph this with fractions. Do I need to graph it with fractions right now for you, or can you guys handle that? Do I need to do that? I'm seeing shakes of head, no. Okay. Questions that you have? Here's another one. And looking at Nick's work up here, Nick jumped straight from the inequality to writing it as a compound inequality. Some of you may have needed to start out with 2x plus 3 is less than or equal to 9, and the 2x plus 3 is greater than or equal to negative 9. Nick wrote it here right away. Notice this is that first one, that addition one, and then he put the negative 9 over here, and notice how the symbol looks. It looks like the same thing, doesn't it? But when we read it backwards, it's really flipped around with that negative. And then he can go through and solve it as a compound inequality. Now, what I do want to note here is if you do it with the two inequalities and you're having troubles getting it into the way that Nick had it up here, you can go ahead and solve each one of these inequalities. So I'll have 2x greater than or equal to negative 12, x greater than or equal to negative 6, with the and in between. You still have to write that as a compound inequality in the end. The negative 6 and the 3 with your symbols in between. You still have to end up with and statements, writing it as a compound and. So if you are having troubles with what Nick showed us here, and you want to solve each of those ands independently and then put your answer together at the end, that's legitimate. Any questions there? How we doing? Pretty good? Feel like a truck hit you? No? That's good. That's good. And it's not overload. Let's see what I have here. No, we're not doing that. Okay. All right. Questions? Sam,